Hello friends, welcome back to Accurate Brains. So in the previous video, in this video, right? So in this video, we have learned such things like rational numbers, but I explained in an embarrassing way that I felt guilt. So in this video, we are going to start our new series, which is nothing but one. Okay. In the starting, I'm making the mistakes, right? Okay, today we are going to start one short series, so that physics wala also runs one short series in for every chapter. He only takes only one video, so here also we are going to start our one short series in our Accurate Brains. So okay, let's start our today's session. So I am your Ruthvik Teja. So let's try with physics wala. So today the class number 1 of today we are going to learn maths. So here first of all we are going to check the definitions and the basics of the mathematics. In the rational numbers chapter we have to learn that. So in the first, what are natural numbers? So if you didn't watch our mathematics basics and physics basics classes in our if you didn't watch, so you can watch it in my channel. So natural numbers. So here natural numbers is nothing but the set of counting numbers are called natural numbers. So here, what are the counting numbers? Here you got it out. So simply we if we watch any school, so that in a classroom there are 1, 2, 3, 4, 5 benches. If one here, how many persons are there? So you tell 1 and 2. So there are 2 persons are there. So these counting numbers. So the numbers which we start from 1 and up to infinite. So infinite means unlimited numbers. We have, you know that we have unlimited numbers. The unlimited is nothing but infinite. So the infinite symbol is represented by this. So this topic is clear, I think. So the set of counting numbers are called as natural numbers. Here are 1 to infinite. So unlimited, infinite means unlimited, and these natural numbers are represented by the letter N. Okay, so N is equal to, so what are N? What are the numbers N? So here 1, 2, 3, 4, 5 and dot 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 dot, which is nothing but this symbol also represents the infinite, so that many are there. So this also represents infinite. So natural numbers are nothing but the set of counting numbers are called as natural numbers. Here natural numbers. So here they are represented by the letter capital N. So they are started from 1 and ends with infinite. So the last number of natural numbers are infinite. So okay, this topic is clear. Here after this, the definition of whole number comes out. So okay, simply, so whole numbers, right? Whole numbers. So here the set of counting numbers. Okay, the set of counting numbers. Here same as it is definition, but the set of counting numbers and we can say including 0 is called whole numbers. So here whole numbers are nothing but the set of counting numbers. Counting numbers are nothing but the natural numbers, right? So the set of natural numbers including 0. For example, we have counting numbers like 1, 2, 3, 4, 5, 6, and the whole numbers are nothing but, so first of all they are represented. So if we talk about representation of whole numbers, they are denoted or represented by the letter W, or we can say capital W. So capital W is equal to, whole number starts from 0, as we know that counting numbers are 1, 2, 3, 4, 5, 6 and so on. So this symbol represents infinite. So here if we check about natural numbers or counting numbers, so we can say it natural numbers because it is denoted by capital N. So here counting numbers are 1 to infinite. These are natural numbers, right? These are called natural numbers which are 1 to infinite. But here, okay, 1, sorry, not from 1. So here 0 to infinite are known as whole numbers. So whole numbers starts from 0, 1, 2, 3, 4, 5, 6, 7, 8 and infinite. So but natural numbers are start from 1 to infinite. So that means natural numbers are similar with whole numbers. And here we are going to learn a property that is, so okay, that is, so 1 second. Okay, I'm not like physics wala that I can click here a button though, so that board can rub out. Okay, right? Okay, so these are natural numbers. 1 to infinite are natural numbers and 0 to infinite are whole numbers, right? So we know this, right? So here every so here is a property, so you can note down it. Every natural number, n is denoted for natural numbers. For every natural number, sorry, for every not, so every natural number is a whole number. So you can see that the symbols, n means natural numbers and w means whole number. So every natural number is a whole number here, but every whole number need not to be a natural number. So here we are going to simply understand it. So what are natural numbers? They are 1 to infinite, so they are including in whole numbers. So whole numbers are nothing but 0 to infinite. After 0 what we can write? So once we write down the notation of whole numbers and natural numbers, so if we look at it, so W is equal to 0, 1, 2, 3, sorry, okay, 0, 1, 2, 3, 4, 5 and so on. So these are nothing but whole numbers and n equal to 1, 2, 3, 4, 5, 6 and so on. So here what are the common numbers between whole numbers and natural numbers are nothing but 1, 2, 3, 4, 5 and so on. So all are similar, exception case is 0. Here every natural, okay, it rubbed out, so okay, sorry for that. So every natural number is a whole number, but every whole number need not to be a natural number. So here 1, 2, 3, 4, 5, yeah, all are same, but except 0. So 0 is not included in natural numbers, so that both are not same. So but every natural number 1 to infinite are included in whole numbers, so that every natural number is a whole number, but What are whole numbers? Whole numbers are nothing but including 0. So every whole number need not to be a natural number. So here, because of 0, both are dissimilar. So that we completed our property. So our next topic will be okay, we completed 3 topics, right? A property and natural numbers and whole numbers. Right, 3 topics we completed. So that okay. So many topics are left. So our fourth topic is nothing but integers. So our fourth topic is integers. So here integers are nothing but set of so integers are nothing but the set of whole numbers, or okay, we split out, okay, the set of positive numbers and negative numbers. So here the set of positive and negative numbers including 0 are called integers. So here integers are nothing but the set of or the combination of positive numbers, negative numbers and including with 0. So here we have to know that what are positive numbers, what are negative numbers, what is 0. So here first of all our topic. So I request you to note down this definition so I can rub it. So you can pause the video and note it down so that I can rub it. So okay, I am rubbing it. Okay, and here positive numbers. First of all topic, positive numbers. So here positive numbers are nothing but for natural numbers 1, 2, 3, 4, 5 and so on. Here positive numbers are nothing but the numbers which are non-negative. Non-negative means that which have only the number but no sign is included in front of it. For example, we take -7. This is not a positive number because in the front of the number, so there is the sign of minus. So here we have to remember a point. So if we take 1 or 2, so there are no signs here, no sign. So here there are no signs, signs, signs. So there are no signs behalf of them, that means in front of them. So we consider them as +1 and +2. So if there is no sign in front of any number, that is considered as a positive number. So that the positive numbers topic is finished. In integers, positive numbers are nothing but the numbers which have plus or no sign in front of them. So positive numbers are clear. So here our next topic, negative numbers. Negative numbers. So here negative numbers comes into play when there is a sign which is called as minus, right? So -1, -2, -3, -4. So here and so on, -4, after that so on numbers are there. So here if we check this, so after before 1 there is a symbol called minus. This symbol indicates negativity. So -1, -2, -3, -4. So they are minus symbols in front of them, right? So here, so that they are not positive, they are negative numbers. So that minus symbol indicates negative. so that they are called as negative numbers. So is this clear? So once I will revise that. So if any number have minus sign, which means subtraction sign in front of it, so it is considered as negative number. So this topic is clear, I think. And our next, what is zero? So here I explained positive numbers and negative numbers, but you have a doubt, then what is zero? It is positive or negative? So you might raised several questions in our mind, but zero is nor positive or negative. So here 0 is nothing but a neutral number where it is not positive or negative. So if we consider 0 as neutral, so here we have totally 3 types of numbers in integers, right? So -1, -2, so which are called as positive numbers, they are called as negative numbers. So 1, 2, 3, 4. So here 1, 2, 3, 4, 5, 6, and so on, they are called as positive numbers, and -1, -2, and -3 and so on, they are called as, these are called as negative, these are called as positive. So what is about 0? Is there any special? So nothing. So they are called as, 0 is called as neutral number. So here we have to assume a point that 0 is neutral number. It is called as neutral number. So here 0 topic is finished. So here if we see that 0 is nothing but the number which is not positive nor negative is known as 0. So it is also called as neutral number, right? So head to our integers topic. So in our integers topics there are totally 3 topics. So here integers. So here what are the topics in this? So first, positive numbers. So positive numbers. The current is gone, guys. Okay, so let's continue with this. So positive numbers and negative numbers. So next, and neutral number. So here we have totally 3 groups of numbers in integers. So let's mix them, and to form these 3 numbers together form an integer. So okay, first 0 will then be the middle. So okay, I will write here. So if I wrap this, I can occupy whole the board. So since I am using only half of the board, right? So okay, here integers are denoted with z. So z equal to, so here in this is a bracket where in the between, so that the integers can lie. So in the middle, so that here it is neutral number. So neutral number. So 0 is a neutral number. So okay, on the right side of 0, so here 1, 2, 3, 4, 5 and so on. So these numbers are called as, these numbers are called as, we know that, positive numbers. So here this topic is clear, right? So this is neutral number, so which is 0. So on the right side of 0 we have such numbers called positive numbers, and in the left side of the 0 we have such numbers called negative numbers, which are, we know that, -1, -2, -3, -4, -5 and so on. So here we considered positive numbers are as original numbers and 0 as, so for example, if we take ourselves, if we stand on the mirror, in front of the mirror, so we can see our mirror image. So we consider 1, 2, 3, 4, 5, which means positive numbers as ourselves, and 0 as mirror, and negative numbers as our mirror image, so that they are quite reverse. So here 1, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 4. So that we considered as integers. So integers are represented by Z. So these are called as negative numbers. This is called as 0 or neutral. So this is called as positive numbers. Here we completed integers topic and heading towards the rational numbers. Okay, so this took a much of time, so to explain me the integers, right? So okay, I think all the topics are clear until now. If you don't, you can ask me the doubts in the comment section below. So okay, heading to our next topic, rational numbers. Here, rational numbers. So here rational numbers are nothing but the representation of numbers in the form of P by Q are called as rational numbers, and where P, Q are integers Q is not equal to 0. What is Shekunam, guys? So that okay, here we are starting our topic. So rational numbers. So the representation, the showing of numbers in the form of P by Q. P by Q is nothing but the fraction form of numbers. So for example 4 by 5, which is a rational number. So the representation of numbers in the form of P by Q, this is the main topic. So where P and Q are integers, P, Q are integers, but Q is not equal to 0. Some accurate brains might have understood, but some brains like me don't understand that. So that okay, here we go into deep like that. So representation of numbers in the form of P by Q. Here P by Q is nothing but division of numbers, you might think, right? So division of numbers is nothing but P by Q. For example, we take 4 and 20. So to divide them, we will use our old technique called division, right? So like this. So simply we can do that. So not such long process, nor short. So that is a medium process to simplify numbers into simplify numbers. So here we can write what a Shekunan, guys. Okay, here we got that. So 4 is nothing but P and 20 is nothing but Q. So here we have to follow these two properties. So where P and Q are integers. So P and Q are integers, right? So 4 is an integer as we study right now, right? So 20 is an integer, right? And P and Q. So P and Q are nothing but variables, you think so that variables can change any value, that but here variables are constant. So where P and Q are the integers, right? So 4 is an integer, 20 is an integer, but Q is not equal to 0. Q should never be 0 in the form of rational numbers. So here, so the Q is nothing but 20, right? So you might think that Q we have 0, so it is not a rational number. Not like that, guys. 4 by 20, it is a number whole 20. So 20 is a number, right? So this whole number is not equal to 0. So 20 is not equal to 0. So that it is a rational number. So accurate brains activated, right? Okay. For example, we take many examples. So solve that. Okay. And here. And okay. For example, we take -7 by 2. Here this is a rational number or not. So here we take the definition as a reference. So P this is Q. So we have a point, right, where P and Q are integers. So -7 is an integer, comma 2 is an integer, right? So they both are integers. So our first point should clear. And our next point, so 2 should be equal, no, sorry, so P, sorry, what I am talking, boy, okay, 2 should be not equal to 0. 2 is not equal to 0, right? Oh, so okay, this is a rational number. We consider it as a rational number. So here the topic is finished, so that we can take more topics. The one shot series is very hard, right? So how can physics wala make this topic? Okay, heading to our topic, next topic, so that addition of rational numbers. So addition of rational numbers, right? So here addition of rational numbers comes into play when two rational numbers are getting added. So here, for example, 2 by 3 plus 4 by 2. Here we have two such rational numbers which are nothing but 2 by 3 plus and 4 by 2. So here we are going to add these two numbers to make it another rational number. So here 2 by 3. So 2 by 3 as it is plus 4 by 2. So here first we know that to add fractions we have to take the LCM of denominators, right? So here what is the LCM of these denominators? What are the denominators? First of all 3, 2. Here these both are prime numbers, right? So these both are prime numbers such that we have to multiply them, because these two have no other factors such as 2, 3, 4, 5, 6. So okay, 2 is a factor of them, 3 is also a factor of them. Prime numbers are nothing but the numbers which have only factors as 1 and itself. So 2 and 3 has no other factors, it has only 1, so that we have to multiply it. So 3 into 2, which is nothing but 6, right? So the LCM of 3 and 2 is 6. So here, okay, I have to rub it. Okay, some of the accurate brains also understand this topic easily. So here what we got, LCM is equals to 6, right? So here what are the fractions? 2 by 3 plus 4 by 2. So here we have to multiply. So what is this 6 in 3 table, right? So 3 into 2 we get 6. So as we told that, so to multiply to get this number we have to multiply denominator to such a number, so that such number should also multiply with the numerator. So 2 and 2, so 2 into 3 should get 6, and also the numerator multiplies the same 3. So here this topic is clear, right? So if we multiply by 2 2s are as 4 by 3 2s are as 6 plus 4 3s are 12 by 2 3s are 6. So here we got this, which is equal to 4 plus 12 by 6, right? So if we add 4 and 12 we get 16, right? 16 by 6. Here we got a rational number, but we can cancel it if you observe carefully. Here these both numbers are divided by 2. So okay, so 2 3s are and 2 8s are, right? So which is equal to 8 by 3. It's a rational number, right? So here we got a point. Therefore if we add two rational numbers we get another rational number. So this point is important, that if we add two of the rational numbers in so like that, so 2 by 3 plus 4 by 2, so here if we add these two numbers, so we get another rational number, right? We don't get such numbers like 3, 2, 3, 4, 5, 6. We don't get like, right, that. So if we take such that numbers, so we take if we get, for example, if we get 5, it is also a rational number, as I told you in my basics class. So 5 is also a rational number which can be written as 5 by 1, where p and q are integers and q is not equal to 0, 1 is not equal to 0, right? So it is a rational number. So here we got this point. If we add two rational numbers, we get another rational number. Topic finished. Addition of rational numbers finished, right? So here if we go ahead, so we get subtraction of rational numbers. So the whole topic is same, guys. If we the addition and subtraction of rational numbers are pretty similar, but here we have to, for example, we take the same example, 2 by 3 minus 4 by 2. So here directly we have to do that. So the LCM is 6, right? So if we multiply that, so 4 by 6 minus 12 by 6. So here we are taking these two rational numbers into the multiplication. As I told you that in addition, so we have to just replace the sign and we have to subtract them, okay? So here all the denominators are 6, so 4 minus 12, which is nothing but minus 8 by 6. If we clear carefully, so these both are, this 6, 8 minus 8 by 6. If we observe carefully, these both are multiples of 2, so 2 minus 4 are, so 2 3s are, so minus 4 by 3. It's a rational number. So here we got another point, that if we add we combine the 2 points, right? So if we add or subtract, we will get another rational number. Clear, right? So okay, we finished another topic, that is subtraction of rational numbers. So here another topic, multiplication of rational numbers. So this is such easy. So take the same example, guys, multiplied by 4 by 2. So here we take the same examples. 4 2s are 8 by 3 2s are 6. Completed. This is multiplication of rational numbers. You don't believe me? Seriously, guys. So if we have two rational numbers, so that we have to multiply the numerators and denominators. So 2 4s is nothing but 8 and 3 2s is nothing but 6. Here we got another rational number. So we have to combine that point. So if we add, subtract or multiply any two rational numbers, we get another rational number. Okay, we got that. Okay, 1 minute. So here we are. They both are multiples of 2, so that 3 is 4 by 3. Right? Clear? Okay, they are completed. Okay. Here, division of rational numbers. So take the same example, 2 by 3 divided by 4 by 2. Here we have to divide these both. So how we divide? In the form of rational numbers we have to do. So this is a rational number, this is a rational number. This is a rational number. So we have to write it in the form of fraction. So 2 by 3, 4 by 2. So this type of fraction is known as complex fraction. So here, so if we reciprocal 4 by 2, it will become 2 by 4 and it will multiply with this rational number. This is a rule. So if we reciprocal it, so we get 2 by 3 multiplied by 2 by 4. Here we got this, right? Simply we got multiplication. So 4 4s are 4 4s are 2 2s are 4. Okay, so 3 4s is nothing but 12. These both are 4 1s are 4 3s, which is the answer is nothing but 1 by 3. We got the answer. Here, here, here. Actually, brains समझ गए होंगे. So I'm still picking anything. Okay. Okay, starting onwards. Okay. The one shot series is very hard, but I am explaining you guys so that you can hit my subscribe button and like my video. So that if you have any doubts, I can clarify in the comment section, because none of them are commenting, right? So okay, let's go on to the further topics. So this is a major important topic. Finding in between rational numbers. So here, for finding in between rational numbers, for example, we take the same example, 2 by 3 comma 4 by 2. So here these both are rational numbers. I am getting sleep, guys. Okay, you don't sleep, guys. Please by watching my video. You don't have to sleep because your mother will bang me. So that, okay, I will be active, you will be also active. So here we have two rational numbers. So to find these two in between, here, not here, in between two rational numbers, we have to find another rational number. So to find that, formula will be a plus b by 2. So this is the formula to find the in between rational numbers of two numbers. So here, for example, we take the same example. How many examples we take this? So that, okay guys, here you might be thinking why I am taking the same example, because if you take any of the examples you get the same answer, right? So if we take 2 by 3, so the formula will be a plus b by 2. So here this is the formula. So this is we will consider as a, and this is will be considered as b. So 2 by 3 a plus, and b will be 4 by 2 divided by 2. So here we have to add these two fractions. We already got in the addition of these two fractions. What is that? I forgot that. So 6, this will be 4, this will be 12, and that will be 16 by 8, right? Sorry, 16 by 6. 16 by 6 by 2. So here we have to again reciprocal. 2 by 1 we can write as 2 we can write as 2 by 1, right? So by this, so okay, we have another topic. So here they are multiples of 2, right? So 2 3s are and 2 8s are. So here we have to reciprocal this rational number 2 by 1, which is nothing but 8 by 3. So as I discussed in the division of rational numbers, we have if we have two rational numbers, we can reciprocal the denominator of rational numbers and flip it and put it in the side of the rational numbers, and we just multiply it. So that 8 by 3 multiplied by 1 by 2, simply, right? So 8 ones are 8, and the denominator 3 into 2 is nothing but 6, right? 6. We got the in between rational number between two these numbers. So here this rational number is considered as, I stopped my video, right? So here 4 by 3 is nothing but q1. They are represented by the letter q, and how many rational numbers we are finding, so they are represented by the numbers. So teaching is very hard. Okay, no problem. Okay. Finding in between rational numbers topic is finished. So here if we move on to the next topic, we have a loss of rational numbers. So here we have loss of rational numbers. So loss of rational numbers are nothing but the properties of rational numbers, not the properties, right? Okay, there are 4 types of loss in the rational numbers. So closure law, So second one is commutative law. So third one is associative law. Okay, sorry, I'm writing the spellings wrong, guys. Associative law, and the fourth one is distributive law. So as I told you that I went up on commutative law after my video that shut down. So okay, so if we look ahead on the closure law, so closure law is nothing but, so if we add, therefore if we add two rational numbers, we should get another rational number. So as I told you in the addition of rational numbers, okay, I'm losing my energy. So okay, refill. So accurate brains don't fall asleep. So here, if we add two rational numbers, we should get another rational number. So here, for example, as I told you in the addition of rational numbers, so this point should be noted down in your notebooks, as I told you in the addition of rational numbers, so that if we add two rational numbers, we should get another rational number. Okay, as I proved that in addition of rational numbers, I have no energy. Okay, so I said that in the starting videos that teaching is very easy, but teaching is very hard. Okay, leave out that. So let's concentrate. So subtraction. Sorry. Okay. Heading to the topic, commutative law. Here, commutative law. So here, commutative law is nothing but the changing of order of number. So if we have a plus b, where a and b are rational numbers, they should be equal to. So here, a plus b should be equal to b plus a. B plus a. So this law is known as commutative law. For example, we take the same example. So 2 by 3 plus 4 by 2. So here should be equal to 4 by 2 plus 2 by 3. So this should be equal. So we will get this as 16 by 8. By God's grace, we have done it in the addition of rational numbers. So for this will be 6 and 12 plus 2. This will be also 16, and so here denominator will be 6, right? So here 16 by 6, it should be equal to 16 by 6. So that commutative law over addition is true. And if we make that as we hold this, so we have commutative law over subtraction, right? So take the same example. 2 by 3 plus 4 by 2 should be equal to plus, not plus, so here we should take minus. So 4 by 2 minus 2 by 3. Hope I am boring of these classes, right? So you might boring of these classes, but you have to refill the energy. So okay. So here LCM will be 6, and so as I taught you subtraction of rational numbers, I am doing directly of the subtraction of rational numbers. So here 4 minus 4 and so here we in the commutative law over subtraction. So here commutative law over subtraction. we get the signs different. This will be plus and this will be minus. So that minus 8 by 6 is not equal to 8 by 6. So that commutative law is not satisfied over subtraction of rational numbers. Okay, let's go to multiplication. Okay, over multiplication. So okay, commutative law over multiplication is nothing but, so here if we multiply through okay, should be equal to, if we multiply two rational numbers, it should be equal to reverse order of this multiplication, so that 4 by 2 into 2 by 3. Simply you can notice that they are reversed and flipped and ordered. Okay, so here we will get 8 by 6 should be equal to 8 by 6. So here over multiplication we get that commutative law is satisfied. Commutative law of over multiplication is finished, and going to the commutative law over division. Okay, let's do that. So okay, over division. So division, over division, right? So 2 by 3 by 4 by 2 should be equal to 4 by 2 by 2 by 3. So here we are going to divide this as I taught you in the division of rational numbers, so I am doing directly. So okay, 4 by 12 is equal to, and 4 by 12. So here, as we discussed in division of rational numbers, so we get 4 by 12 and 4 by 12. So if we cancel them, so 4 ones are 4 threes are 4 ones are 4 threes are, we get 1 by 3 is equal to 1 by 3. So here commutative law over division is satisfied under rational numbers. So commutative law of division is completed. Whole commutative law is completed here. So heading towards the, what is that? Okay, associative law. Okay, right. Associative law. So as we discussed associative law, we didn't discuss that. Okay. Associative law. What is associative law? I think A plus B plus. Okay. Here I about the associative law. So if we take A, comma B, comma C as rational numbers. So rational numbers. Okay, I'm so very sorry. So rational numbers are denoted by Q. So A, B, C. As I covered it in the as rational numbers, basics of mathematics. So A, B, C are rational numbers. So associative law. So A plus B plus C. So here alphabetic law is nothing but first A and B should be added, which is equal to. So in the LHS we have to add first as A and B. So and in the RHS A plus B plus C. So here in the RHS B and C should be added first. Okay. So for example, we take the same examples by adding a number of C. So 2 by 3 plus 4 by 2 plus a number that 9 by 4. Okay, 9 by 4. It should be equal to, so 2 by 3 plus 4 by 2 plus 9 by 4. Simply, right? Okay, I am doing it directly from here. So add these two. So if we add them, so we get 16 by 6, right? We get 16 by 6 plus 9 by 4 should be equal to 2 by 3 plus 4 by 2 plus 9 by 4. Okay, I am doing it directly. uh, 17 by 4. So here we have to make this should be equal, not should be equal, right? Like, so if I take this here, so 6, the LCM of 6 and 4 should be, I think that is 12, right? 12 and 6 and 4, 12, right? 6 and 4. So 2 3s are 2 2s are, so 3 1s are 2 1s are, 2 3s are 6, 2 6 2s are 12. So right. So 6 12, right? 16 2s are 32 plus into 3 27. So 32 plus 27 is nothing but, what is that? Okay, right? 59 by 12. So here we got the LHS side. So coming to the RHS side, so here if we make that add 12 and 4. So I don't know the tables, guys, so I'm not an accurate brain, as I created the channel accurate brain, but I know the theory part and all of the topics, but I don't know the tables. Okay. Okay, 5. Okay, 51 and 51 plus 6, right? Into 4 plus 8. Okay, here we got 59 by 12. So both LHS and RHS are equal, so that associative law is satisfied over rational numbers. Associative law is completed, guys. So we can apply this to subtraction, multiplication and division. So okay, associative law is completed, and the distributive law will be discussed in mathematics basics part 2. So if you want to watch that, please subscribe to our channel Accurate Brains. And our next okay, I will talk about next what is that, next second chapter, surds. Here surds are discussed in the next one shot series, and if you like this video, please subscribe to Accurate Brains and leave a comment how I teach, and if you have any doubts you can ask me in the comment section, so that you can't get any doubts. So you have to subscribe to Accurate Brains so that you will get free education, and don't forget to listen the classes in the school. Okay, right? So our second topic will be surds, should be continued in the next one shot series. And thank you for this session. Subscribe to Accurate Brains and stay tuned for the surds.